So you have seen that it is symbol like Trisul, on my t-shirt, and this type of symbol, like this type. Okay, so this type of symbol name is basically psi. This is called a wave function. So uh, today I am going to recollected this type of things, and also I want to introduce the function name of the wave function, and also the meaning of psi. So as you know that a photon has a like both a photon has two nature, like a particle nature as well as wave nature, wave like nature. Okay, so in this session an electron is an electron who has a particle like as well as a wave like character. So in both cases the object photon and in both cases like particle and wave cases, the photons or electrons are always detected as a particle. Photon or electron always detected as a what? Particle. Okay, so so in it interacts with another material as well as particle, but the probability of its being found at a place is governed by the waves. Okay, and that always is accompanies the object. Understand that the wave is described in terms of the electric field as well as this wave function is also described in terms of electric field as well as magnetic field. In terms of electric field as well as magnetic field. Okay, so for that case the exert force on the particle and so on. Okay, but the wave quantity associated with an electron or a material of the particle is very abstract and does not corresponding to immeasurable quantity. Okay, and it involves with complex number the complex number and the square root of negative numbers. Okay, so it involves with complex number. Now the most valuable thing that psi for any material it represented at for any the wave quantity associated with any material, the wave quantity associated with any material, okay, particle, psi is equal to r of t. So and we call it that the wave function of the particle. We called it wave function of the particle. Psi of r comma t is called as wave function of the particle. Okay, so here at this in this function is said to be represented at the state of particle, and it given the location. Here you can see that the r psi of r comma t, where r represented the location and t represented for time, for time. Okay, clear brother. So the values of the changes with time t at the given time, its value of different at a different position. So the connection between wave function and the probability finding of electron here, electron there. Okay, and this is called Bond's interpretation of wave function. Let me now let describe. Let's say I'm taking that is the three dimension like x axis, y axis and z axis, and let's say there is a material with a r distance and r d tau. Okay, so consider a point in the position vector r, let's say any position vector, and constructed a small, this is a constructed a small volume, okay, dr del r, okay, around the point, okay. So the probability of the finding of the particle in the volume of time, so dp will be c of psi star or r comma t psi of r comma t d tau, where is equal to c of psi of r comma t modulus of r square d tau. So where psi star r comma t is complex conjugate, where psi star of r comma t represented complex conjugate, it is clear that what is the psi star of r comma t represent complex conjugate. So and c is constant, here this c is constant, okay. And the probability of the finding of the particle will must be the finding probability of the particle of somewhere enter the space will be must be what, must be 1, okay. So for this means that integration of c of psi of r comma t star of d tau is equal to what, is equal to will be 1. So one can multiply the wave function by an appropriate constant. So here I am writing, you can write that one can multiply the wave function by the wave function psi of r comma t by an appropriate constant, by a appropriate constant, okay. So by a appropriate constant you can define it, okay. Is it clear? Then what will be, then integration of psi of r comma t modulus of d tau is equal to 1. Here the function in such cases is called normalization. This function is called normalization. This function is called normalization. For such wave function we you can take c is equal to 1 here, okay. So that you can take dp is equal to psi of r comma t d tau, clear. So dp divided by d tau will be what, modulus of r comma t psi square, sorry. So this is called the probability density. This function is called probability density of the function psi, okay. The probability density of function is psi, so the multiplication of psi of r comma t is constant. So here I can say, you can say that a multiplicity psi of r comma t is equal to constant, by a constant, okay. And which is c, okay. And it turns out that the state of particle is related to the form of wave function of psi of r comma t, and it's not value. So so here you can see that psi of r comma t and c psi of r comma t, okay. represent the same state of the particle, represent the same state of the particle. Okay, represent the same state of the particle, and it convenes to choose the constant, মানে it's convenes to choose the constant such that the wave function is normalized. Okay, and here you can use মানে here you can use this equation, মানে which this equation for the probability. So মানে dp is equal to psi of r comma t normalization square d tau. This equation you can use for the probability. Okay, I am writing very much very much speed. Okay, so my writing ability always was it was very high. So on a very high speed I always try to maintain it. So I have to tell you that how many things about the quantum system which will need your at the serious attention. So if you want to keep the mathematical computation as the low possible to begin, then you will make a simulation, okay, sorry, simplification with the very realistic, but it will help you to understanding few ideas faster. And I will assume that your space is one dimensional and your phenomena have to occur only on the x-axis. The wave function of the particle is written as I have already told you that psi of r comma x comma t. So finding the particle in the range, so finding the particle in the range x, okay, x to x plus del x is what will be is it will be psi of r comma t modulus square, the probability density. So the probability density is density will be what? Density will be this, মানে psi of r comma t, sorry, psi of r comma t. Here you can say this I am writing this psi of মানে r comma t, but when you will take x or del x plus del x, then it will be psi of x comma t. Clear? I think it is clear.